Hello everyone, and thank you for tuning in. Now, to get the most out of this practice test, please pause the video to work each problem before revealing the answer. You can also download a copy of the practice test through the description link down below. Now, by watching this video, you are definitely increasing your chances of getting a high score on the final exam. Now, I'm going to work through the problems quickly but thoroughly so the video doesn't become longer than it has to be. So you don't have to watch the entire video in one setting. You can skip through frames and or take a break as needed. So let's get started. Section 5, Radicals and Radical Functions. Number 41, use rational exponents to write as a single radical expression. So what is the correct answer? Choice D. So here we're given two radical expressions and we're asked to write them as one single radical expression. So to do that, the first thing we would need to do is to rewrite both as rational exponents. So for the first one, recall to write it as a rational exponent, the numerator would be your power and the denominator would be your root. So looking at the first expression, notice we don't see a number that this x is raised to. When we don't see a number, it's assumed to be 1. So the power would be 1. Over here we have the root. The root would be 9. So that would be x raised to the 1/9 power. Let's look at the second one. For the second one, the power we have is 2. That would be on top. Here we have a root of 3. And 3 would go under the bottom. So that would be x raised to the 2/3 power. So the next thing we need to do to solve this is to apply the product rule, and the product rule states that if the base is the same, which the bases are the same of x, keep the base of x and add the exponents. So to add these two, notice that they are unlike fractions, so before we can add them, we have to write them as equivalent fractions. So notice here that the LCD then would be 9. So I would need to multiply the top and the bottom of the second fraction by 3. When I do that, then I will have equivalent fractions here. So 2 times 3 is 6. So I have 6 plus 1, which is going to give me 7 over my common denominator of 9. Lastly, all I need to do is now to rewrite it as a radical, and rewriting it that way, notice this is the power, which is over here, and at the bottom we have our root, which is here. Okay? Number 42, simplify. So what is the correct answer? Choice A. So here we have a cube root, and we're asked to simplify it. Well, first of all, looking at the number, 81 is not a perfect cube root. So we're going to have to look inside 81 and see if there are any perfect cubes inside 81. So one thing we can do is just simply look at the factors that it involves. For example, we can say what two numbers, when we multiply them, will give us 81. Well, 9 times 9 will give us 81. Well, 9 is still not a perfect cube, so let's see if we can break one of these 9 down further. 3 times 3 is 9, and so voila, I do see now that I can make a perfect cube by multiplying 9 times 3 is 27. That's a perfect cube, which means I would have 3 non-perfect left over. Next, I want to look at my variable of a raised to the 5th power. That is not a perfect root. However, if we go down 2, it will be divisible by 3. So if we look at our B is a perfect cube, so we can solve it as is. We don't need to change it. So I'm going to go ahead and let you take a look at how I've arranged it here with the perfect and the non-perfect with the non-perfect. So notice here I have that 27 that we found to be inside of 81. Notice I had a total of 5 A's, but it wasn't divisible by the index of 3, so I had to go down to 3 to make it divisible by 3, which means the other 2 are left over, and they will remain under the radical symbol along with the 3. B was perfect, so it's fine. So now we can go ahead and solve all of this perfect cube, and then it's going to go outside. And what's going to remain under that radical symbol again is 3a squared. So we're left with here 3ab cubed, cube root of 3a squared.
Number 43, simplify. So what is the correct answer? Choice C. Notice this expression is a fraction raised to a negative power. And remember, we can't have negative exponents in algebra, so we need to use the negative exponent rule to rewrite the expression with a positive exponent. And to do that, you're going to have to flip the fraction. So whatever's on the top goes to the bottom, and vice versa, whatever's on the bottom goes to the top. So when we do that, notice the expression now has a positive exponent. So now we can proceed with solving this particular problem using the rational exponents rule. Recall that the bottom of the fraction is our root, and the top is our power. So to convert this as a radical, that will be cube root raised to the 4th power. So let's go ahead and write it. So there we have it. Now all we have to do is find the cube root of 8, and then the cube root of 125, and then raise it to that power. So the cube root of 8 we know is 2. The cube root of 125 is 5. So we have to take that now and fraction there of 2/5, which is our answer, and raise it to the 4th power. So recall that is the power rule. So 2 to the 4th power and 5 to the 4th power will give us the answer of 16 over 625. Choice C.
Number 44, simplify. So what is the correct answer? Choice B. So notice here we're given a radical expression in the form of a division. So we're going to use the quotient rule here, which is simply divide the coefficients. So 40 divided by 2. And then we're going to use the quotient rule for our exponents. So recall, if the base is the same, keep the base of x and subtract the exponents, and that will be top, take away the bottom. So when we rewrite that, we're going to have 20 x to the 3rd power. Now we know that 20 is not a perfect square root, but it does have a perfect square root of 4 inside. In terms of the variable, x to the 3rd power is not a perfect square root, but we can simply go down 1 and make it perfect. So x squared would be perfect, which means we would have 1 x left underneath the symbol. So
If I were to just group it and put the perfect with the perfect and the non-perfect with the non-perfect, the perfect part would be the 4 and the x squared that are inside. And then the other part, which is the 5x, that would be your non-perfect. And so that will remain underneath the radical symbol. So let's go ahead and solve the perfect. So the square root of 4x squared would be 2x, which gives you the answer. And remember, when you solve it, it goes out in front. So the answer would be 2x radical 5x, or you can also say it as 2x square root of 5x. Choice C. Number 45, simplify. So what is the correct answer? Choice C. That is correct. All right, so here we are adding and subtracting radicals. So remember, you cannot add or subtract unlike radicals. So if you look at the radical expression right now, you cannot add or subtract it the way it is now. So step one, the first thing we're going to need to do is to simplify and extract any perfect roots that are inside. So I know with this second term here, there's a perfect 4 inside. For this last term here, there's a perfect 9 inside. So I need to first extract those perfects from those terms. So when I do that, notice here, again, those are the perfects that are inside. So remember, when we solve it, it goes on the outside. If there's a number already out there on the outside, such as the second expression, yes, we know the square root of 4 is 2. That 2 is going to come outside and multiply with this negative 2. For the last expression, the square root of 9 is 3. That 3 is going to come outside and multiply with the 4 that's on the outside. So when we do that, it looks like this. So we can go ahead and multiply them. Negative 2 times positive 2 equals negative 4. We'll have 12 here. So I'm going to go ahead and bring those terms down. And notice what we have here. Notice the radicands are the same. So therefore, these two expressions are what we call like radicals. So we need to go ahead and simplify those like radicals. And recall, if you don't see anything here, we understand there to be a 1 there. So we have 1 combined with a negative 4, which is going to give us negative 3. Keep our radicand of 3x, and that's going to leave us with negative 3 radical 3x plus 12 radical 2x. Now notice that the last term, there was nothing more that you could do with that last term of 12 radical 2x because it was already simplified. So then this leaves us with our choice C. Number 46. Simplify. So what is the correct answer? Choice C. So notice what we have here are two radicals that are being multiplied. So we're going to apply what is called the product rule for radicals, which state that if the indexes are the same, meaning their root of the radical, all we have to do is simply multiply the inside with the inside. So with the coefficients, you're going to multiply the coefficients and you're going to add like bases of the exponents. So let's go ahead and do that. And so what I'm left with when I complete that process of multiplying the coefficients and add like bases of exponents, I have square root of 675, a to the 4th power, b to the 6th power. Now 675 is not a perfect root, but it does have a perfect inside of it because 3 times 225 is 675. So the perfect root inside of 675 is 225. Let's take a look at our variable a to the 4th power. That's perfect. Remember, because it's divisible by 2, the index. B is also perfect because it's also divisible by the index of 2. So I'm going to go ahead and organize them together and put the perfect with the perfect, and that non-perfect of 3, remember, is going to be left under the symbol. So when I go ahead and solve that perfect, the square root of 225 is 15 for my variable. It's going to be a to the 2nd power and b to the 3rd power, which is with our radical 3 being left under the symbol, of course. So that gives us choice C. Again, 15 a squared b to the 3rd power radical 3. Number 47, simplify. So what is the correct answer? Choice B. Notice here what we have is a binomial squared, which simply means that we have 2 of the same. So we can simply put them side by side and use what is called FOIL, first, outer, inner, last. Recall when multiplying radicals that you multiply the outside with the outside, meaning those outside the radical, and inside with the inside, meaning the radicands with the radicands. Okay, so let's go ahead and begin the process. Radical 10 times radical 10 equals radical 100. Radical 10 times 2 radical 5 equals 2 radical 50. Inner radical 2 radical 5 times radical 10 equals 2 radical 50. And let's do the last. Outside with the outside. 2 times 2 is going to give me 4 outside. Then I'm going to multiply radical 5 times radical 5, which is going to give me radical 25. So 4 radical 25. My next step then is I'm going to simplify everything and combine like terms. So here I can simplify the first term. Notice outer and inner are like terms, so we can combine them, keep the radical of 50 and add the outside. For the last term, this is a perfect square root, so we can solve it and go on the outside to multiply with 4. So let's go ahead and begin simplifying that process. So there you have it. We can simplify even further by multiplying the 4 times 5 is going to give me 20. We also had a perfect square of 25 inside the 50. So solve that. The square root of 25 is 5. That's going to come out on the outside and join with 4. Multiply there, which is going to give us 20 outside. We also have our outer integers that we need to go ahead and combine, that 10 plus the 20. So this gives us a final answer of 30 plus 20 radical 2, which is choice B. Number 48, simplify. So what is the correct answer? Choice C. So notice here on this expression we have radicals in the denominator. And recall, you can't have radicals in the denominator, so to remove those radicals, you would have to do a process which is called rationalization, meaning to multiply that expression with the conjugate of the denominator. So if the denominator here is 2 radical 7 minus radical 10, the conjugate of that would be 2 radical 7 plus radical 10. So let's go ahead and multiply it, the top and bottom, by the conjugate. So when we do that, our next step then is to proceed with the multiplication process. So on top it's going to be nothing more than distributive property, which is 15 times 2 radical 7, and then 15 times radical 10. On the bottom, you're going to since you have conjugates, you only need to do the letters of F and L, because O and I will always cancel out when you have conjugates. So first, you're going to multiply 2 radical 7 with 2 radical 7. Last, we're going to multiply negative radical 10 with positive radical 10. So when we do that, our expression then becomes this as follows. And on the bottom, notice that I can go ahead and multiply 4 times 7, which is going to give me 28. And then 28 take away 10 is going to give me 18 for the bottom. If we look at the top, there's nothing more we can do with the top, because the top underneath the radicands themselves, they are non-perfect, and there's no perfect inside to extract, so that's all you can do at that point. Now the next thing we can do, though, however, we can factor out a 15, because if you look at the expression previous here, you had 30 here and 15 here, so they had a GCF, a greatest common factor, of a 15, which what I did was simply factored it out. And the reason for factoring that out is I want to go ahead and cancel out any common factors that they have. So 3 times 5 is 15, and on the bottom I have 18, so 6 times 3 is 18. I can cancel the common factor of a 3 that these terms have in common, so I'm going to go ahead and do that. And what I'm left with then, you'll notice, is choice C.
Number 49, solve. So what is the correct answer? Choice C. Now before we begin solving this radical equation, let's go over the rules for solving. Step 1, isolate the radical. Make sure the radical symbol, the radical term, is on the side all by itself. If there are other terms on the side with it, you must move them to the other side. Step 2, apply the power rule. Raise each side of the equation to the power that is the same as the index of the radical. In other words, whatever the root is, raise it to that power. Step 3, solve the equation. And then lastly, step 4, make sure that you check all proposed solutions. Okay, so now that we've reviewed the rules, let's go ahead and solve. So step 1, again, we need to isolate the radical. So what do we need to do to isolate the radical? That's correct. I need to add 2 to each side. Next, what do? That's correct. Step 2 is we're going to square both sides. So since the index of a square root is 2, we're going to raise both sides to the 2 power, or in other words, square both sides. So that process allows us to remove the radical symbol and the parentheses, everything there on the left. So what you have on the left side is x minus 4. And on the right side, what do we have? 8 times 8, which is 64. So we have 64 on the right side. Last step to solving this equation is to do what? That's correct. Add 4 to each side, and x equals 68. Choice C. Last step in solving is to check our solution. So let's plug our solution of 68 into the original equation in place of x. When we do that, we can see that it does check out, and our solution set is 68. Number 50, last one. What is the distance between the 2 points shown? So what is the correct answer? Choice D. So recall the distance formula is you're simply going to subtract your x's, subtract your y's, then you're going to square them, add them together, and then find the square root of them. So let's go ahead. we can identify our 2 points. One of the points is -5, 8. The other point is 4, -3. So we're going to go ahead and plug these points into the distance formula. So recall that double negatives are going to be positive. So -5, but with a negative in front of it, is going to be +5. So that's going to be 4 + 5, which is going to give us 9. With our y values, the signs are the same. Keep the sign and add the numbers, and that's going to give me -11. Next, we want to square these numbers. So 9 squared means 9 times 9, which is 81. -11 squared is -11 times -11, which is 121. Lastly, we need to simply add these two numbers and then find the root of them. Now, in this particular case, this number is a non-perfect root, so we can simply leave it like this. There's no perfect inside, so we notice that our answer choice then is D. Okay, that's it for this lesson. Thank you for watching Math on PowerPoint tutorials. If you liked this video and found it to be helpful in any way, please like it and subscribe to my channel.